Welcome to Summarize Science, your go-to channel for simplifying complex research. Today, we're unraveling a groundbreaking paper titled Language Models That Think, Chat Better. This research tackles one of the most exciting frontiers in artificial intelligence, teaching AI models to genuinely think before they speak. For years, we've marveled at how large language models generate human-like text. But imagine if these AI could go a step further, planning their responses, considering different angles, and even revising their internal thoughts. This capability, often referred to as System 2 thinking in humans, has been a central aspiration for the AI community. It's about moving beyond mere pattern recognition to true, deliberate reasoning. To understand this breakthrough, let's briefly look at how AI models are typically trained. One common method is reinforcement learning from human feedback, or RLHF. Here, AI learns by getting feedback from humans, aligning its outputs with our preferences and values. Then there's reinforcement learning with verifiable rewards, or RLVAR. This approach is fantastic for tasks where there's a clear right or wrong answer, like solving complex math problems or writing error-free code. RLVAR encourages AI models to show their step-by-step, chain-of-thought reasoning. This way, you can see how they arrive at a solution, making the process transparent and verifiable. It's powerful for deterministic tasks, but has a significant drawback for more open-ended interactions. The main issue is that the reasoning skills gained from RLVAR in these verifiable domains don't naturally transfer to everyday human tasks. Think about writing a creative essay, drafting an email, or even planning a simple daily schedule. These require flexible, general-purpose reasoning that goes beyond strict logical checks. In fact, as Figure 3 in the paper illustrates, models specifically trained with math-focused RLVAR often perform poorly on diverse chat benchmarks. They struggle to keep up with standard instruction-tuned models when faced with real-world, open-ended user queries. This is precisely the gap that reinforcement learning with model-rewarded thinking, or RLMT, aims to fill. RLMT pushes the boundaries of AI reasoning into general-purpose chat, where humans routinely think through problems. The core innovation, as depicted in Figure 1, involves training AI models to generate a detailed, long chain-of-thought reasoning before producing their final answer. But here's the key difference. Instead of relying on rigid, rule-based verifiable rewards, RLMT uses a sophisticated, preference-based reward model. This reward model, similar to those used in RLHF, learns to evaluate the quality of responses based on human preferences, even for complex, open-ended scenarios. Figure 2 provides a fantastic concrete example, showcasing an RLMT model's internal thinking process. You can see the AI breaking down a complex prompt, identifying constraints, and strategizing its response before delivering the final output. It's like giving the AI an internal whiteboard to brainstorm and plan, leading to much more coherent and thoughtful interactions. The performance of RLMT is truly a game-changer across various benchmarks. Table 1 clearly demonstrates that RLMT models consistently and substantially outperform traditional RLHF pipelines. We're talking about impressive average gains of 3 to 7 points on critical chat benchmarks, such as Alpaca Eval 2, Wildbench, and ArenaHard v2. Beyond chat, RLMT also delivers solid improvements of 1 to 3 points on other important tasks. These include enhancing creative writing abilities and boosting general knowledge retention. This broad impact underscores RLMT's potential to elevate AI capabilities across a wide spectrum of applications. Perhaps the most striking finding is how effectively these smaller RLMT models compete with, and even surpass, much larger AI counterparts. Take a look at Table 2, which offers a direct comparison with leading open-source and proprietary models. The best 8 billion parameter RLMT model, Llama 3.1-8b, Instruct, surprisingly outperforms GPT-40 in both chat and creative writing scores. It also rivals the performance of Claude 3.7, Sonnet, a formidable thinking model, on key benchmarks. This achievement is particularly significant given that GPT-40 and Claude 3.7, Sonnet are typically orders of magnitude larger. They are also post-trained with far more complex, multi-staged pipelines involving millions of examples. RLMT achieves this with a much more efficient approach, highlighting its remarkable efficiency. One of the most surprising and promising aspects of RLMT is its ability to be applied directly to base models, entirely bypassing the supervised fine-tuning stage. This zero-training setting, akin to DeepSeek R1-0, demonstrates that RLMT can extract impressive performance from models right out of the box. Even without initial SFT, these RLMT-trained base models achieve average chat scores that are significantly higher than traditional instruction-tuned models. In some cases, they outperform them by more than 5 points, despite the latter's complex post-training processes. This suggests that RLMT is capable of reinforcing and unlocking latent reasoning capabilities that might otherwise remain dormant. The researchers delved into various factors influencing RLMT's performance through detailed ablation studies. As summarized in Table 4, the choice of the prompt mixture used during training is absolutely crucial. Utilizing a diverse set of real-world chat prompts, rather than math or jailbreak-focused ones, proved to be essential for boosting general-purpose chat performance. Equally vital is the quality of the reward model itself, which acts as the AI's internal judge. The paper shows that a stronger reward model consistently leads to better performance, not just in chat, but across non-chat benchmarks too. This highlights that carefully curated training data and a robust reward signal are foundational to RLMT's success. Perhaps the most insightful aspect of this research is the qualitative shift in how AI models think after RLMT training. Figure 4 beautifully illustrates this change, comparing the thinking styles of SFT models versus RLMT models. Initially, an SFT model might use a rigid, linear checklist-style plan. However, RLMT-trained models evolved to exhibit richer behaviors, such as explicitly enumerating constraints, grouping ideas into themes, and even iteratively refining their plans. This more flexible and strategic approach closely mirrors how humans engage in complex problem-solving and creative tasks. Moreover, as Figure 5 indicates, these models learn to generate progressively longer and more elaborate internal thoughts and responses as training advances. So, let's recap the profound implications of reinforcement learning with model-rewarded thinking. RLMT is a simple yet powerful recipe that teaches AI models to generate explicit reasoning, much like thinking aloud. It leverages a preference-based reward model to guide this thinking process, making it applicable to any general-purpose task. The results are clear. RLMT significantly outperforms existing methods, pushing the boundaries of AI capabilities. It enables smaller AI models to rival and even exceed the performance of much larger, state-of-the-art systems on open-ended chat and creative tasks. This means we're moving towards AI that is not just knowledgeable, but genuinely thoughtful and aligned with human reasoning patterns. The breakthrough lies in fostering these desired reasoning strategies naturally through the training process. For the future, this research calls for deeper exploration into these emerging AI thinking styles and expanding RLMT's application to even more complex domains. It suggests a fundamental rethinking of how we train AI, potentially leading to more robust, versatile, and intelligent language models. Ultimately, RLMT brings us closer to a future where AI doesn't just process information, but truly comprehends, plans, and thinks like us.